Hello, everyone, and welcome to Rapid Digital Transformation with Real-Time Event-Driven Applications. I'm Blaine Matthew, Chief Marketing and Product Officer at VANTIQ, and with me today is Brett Rudenstein, our VP of Field Service, who will be providing a demo toward the end of this presentation. We're really excited to talk to you today about real-time event-driven applications and how they can power your real-time business operations. So let's dive right in. Well, as you know, business is undergoing really a fundamental paradigm shift these days, and that shift is being driven by many different technologies. Here's just a few examples: IoT, the shift from the cloud toward the edge, AI, machine learning, and really a long list after that. But fundamentally, the business shifts that are taking place include things like the move from products toward outcomes. What companies like yourself, organizations like yourself are increasingly trying to do is to purchase outcomes, not things, but the result of those things. And you're increasingly purchasing these outcomes as a service. You're renting them. You're paying for the outcomes as a service over time versus owning the core technology or the core systems that produce the outcomes. Obviously, there's a move to add in the virtual world to the physical world. The physical world is obviously still very important to our businesses, but the virtual world, including virtual reality, augmented reality, the movement toward creating digital twins of physical systems is becoming more and more a part of our everyday personal lives and business realities. And then finally, and I think this is really a fundamental part of all of this, is the move from a batch mentality toward the world of real time, toward the world of real-time flows of data in and around your organization, the world of being able to take actions in real time based on that data, not batching things up and taking action later, which is how most business operations have been run classically. And if we can really take advantage of these paradigm shifts, we can truly drive growth and transform our businesses, not just technically, not just digitally, but transform the business models and the fundamental trajectory of the business itself. Of course, this is not easy, right? There are a lot of challenges, a lot of complexity. We need to be fast, we need to be agile, and the challenges come in the form of, first, over the last 3 decades, we and you have been building software for your enterprises, and now you've got software everywhere. Many systems, many applications, different platforms, languages, hosted in different places. And increasingly, those systems are incorporating many different types of technology. The speed with which new technologies, we talked about AI, AR, IoT, blockchain, of course, is very hot these days, NLP, natural language processing, and many, many more are coming at you, at lightning speed. And then, of course, fundamentally, one of your key goals is not just to create technical systems, but it's to create systems that make your people more efficient and effective. Most of your organizations are fundamentally built on your people. And you need to figure out not just how to do things without your people, but how to make your people more efficient and effective, leverage their knowledge, experience, the wisdom of them using these technical systems. And then finally, as I mentioned before, you've got probably 2, maybe 3 decades of legacy applications that you've built that you can't just throw away, right? They need to be integrated in as part of the future, as part of your digital business transformation. And so your challenge is to bring all this together, to integrate it all together. You need to figure out what is the brain, what's the nervous system that's going to connect this together, and who's going to do it. And fundamentally, you need to be able to sense what's happening in and around your business, analyze it in real time, and then take action again in real time. That's a non-trivial challenge. And the challenge really isn't going to be met by the standard 3-tier request response applications and architectures that are in your businesses today. For certain things like CRM and ERP systems, it's perfectly fine to take data, put it in a database, which then became data warehouses, which then became data lakes, just an ever-growing, mountain, lake, ocean of data. Then run a query against those databases, produce a report or a dashboard or an analysis, and then take an action later. That's fine for some types of applications. But for many of the kinds of applications that are, again, moving away from batch toward real time, this kind of three-tier architecture just isn't going to do it. If you're trying to run your business operation in real time, your applications are probably not fundamentally going to be based on a three-tier database-centric application architecture. That's not the answer. So what is the answer? Well, the answer, and as as we're learning and as the analysts are increasingly telling us, is real-time, so-called event-driven applications and event-driven architectures. And at a really high level, how they work is you have all the data flowing in and around your organization. It could be from IoT sensors, from your legacy business systems, from third-party data sources, mobile devices, your employees doing things on their mobile devices, many different sources of data. And this is not just data about video files and audio files and Word documents. This is data about the events that are happening in and around your business. The status of systems and people and machines, your assembly line, your supply chain, the location of things, again, in real time, alerts and notifications when a PO is approved or somebody walks in the door of your retail store, or a facial recognition system recognizes an employee or somebody who's not an employee. These are all events, data about events that are happening in and around your business. And the event-driven application takes that data and processes it, analyzes it in real time as the data flows in, as it's streaming into the application, it's being processed in real time. And that application is using that data, is analyzing that data inside of some context that you give it. Some rules, some constraints, some conditions where the data is good, and others where the data is outside of compliance. Maybe, of course, you're applying some predictive analytics against the data streams that are flowing in. So you're adding, yes, some context that's added to the data flows that are being processed in real time. And then here's the sweet thing, because it's not just about creating, real-time dashboards or real-time reports. That's pretty cool, but the important thing is to be able to take real-time action, okay, based on the data. So as the events are flowing in, they're being processed, and then you're able to do things. Relocate machines, assign technicians, stop an assembly line, reorder something, assist a customer now that you know who that person who just walked through the door. And by the way, those real-time actions are all events in and of themselves. So they are also event data flows, which need to flow back into the real-time event processing application and then be acted on. So this is not a left to right flow. This is actually a continuous process where you're always analyzing, always sensing the data, analyzing, and then taking the appropriate action as it's happening. Now let me take this down from the conceptual level to a bit more of a real world use case of an event-driven application. And let's think of a standard field service example, okay? Perhaps you've got some equipment or systems that need to be serviced from time to time. In fact, let's think about a company called Tuja, which is the Airbnb of China. 10 million apartments under managership. And in those apartments, they're setting them up with sensors for, obviously, fire and smoke, for temperature, for water, if there's a problem with the water system, presence of people, security systems. All of this is wired or being wired into these homes increasingly. And that the data about the events that are happening inside these apartments is being reported into an event-driven application. Now, in this particular case, the event-driven applications are actually running on the edge, okay? They're running either in the building itself or in the city. You could imagine it wouldn't make sense to be putting all this data in real time from 10 million apartments into the cloud. The bandwidth that would take would be incredible. So you process those events in real time on the edge. And then when an error condition or a problem is detected or maybe even predicted, that data just goes into the core application, which is running either in the private cloud in their case or on premise, could be running in the public cloud as well. That data is now used to compare against a list of third-party service technicians that are not employees of the company, but that are available to fix different kinds of problems, depending on what the problem is, depending on how severe it is. So the local technicians are found in the database, they're polled in real time, and then the ones that are able to respond to the job now via a mobile app are taken to the location, they're provided the information with the access code, and they're provided what they need in order to begin to address the situation again in real time. Remember, while the data is continuing to flow in, it's possible that the situation might even correct itself before the technician gets there, in which case the service request is canceled. Or the situation might become worse and the person might need more information or a different set of tools before they get to the door. You can just imagine how different this example of field service is compared to the way it is mostly done today in more of a batch mode. Enabling a real-time event-driven application in this use case creates much more powerful outcomes. And of course, field service is just one example of a business operation that could and should be made real-time. You can imagine the notion of a global supply chain, where you have not only your own company-owned elements of the supply chain, but third parties, and being able to not only track what's going on throughout that supply chain through your logistics operation in real time, but be able to take action against issues or concerns in real time. You know, tracking fleets, I think a pretty obvious, obvious example. Again, it's not just about tracking, it's about the actions you can take when issues arise, or how you can optimize those in real time. Smart manufacturing is another pretty common use case where you can imagine how easy it would be to apply real-time principles to this. Smart cities is really incorporating many different elements of these all at once, and of course there are many, many more. You know, frankly, almost any business process, any operational process could be turned into a real-time process and made much more efficient, much more powerful, much more actionable with a real-time event-driven application. Gartner thinks so. Gartner has said that basically, if you're looking at digitally transforming your business, you must be looking at how to use event-driven architectures. That is the fundamental basis to become a digitally transformed business, to turn your business into a real-time enterprise. And so, up to now, we haven't really been talking about VANTIQ itself, but let me spend a little bit of time telling you what VANTIQ's relationship is to this topic. So VANTIQ is a real-time event-driven application development, deployment, and maintenance platform. And there are 4 key elements, and I'll spend just a little bit of time on each of those to preview them now. Create mission-critical applications that have the ability to run anywhere and also operate in distributed environments, that enable powerful human-machine collaboration, and then of course the ability to do this rapidly with agility. That's obviously very important because of the need for speed in our digital transformation that we're increasingly seeing. So let's dive into each of those in a little bit more detail right now. So first, as we've been talking about really up to now, the notion of fundamentally, you need the ability to have a platform that can do real-time processing of complex asynchronous events, what's actually been called build reactive applications. It's, building these things is non-trivial. We'll talk a little bit more about that in a second. And being able to have at the core a system that allows you to build and run these applications, do this processing is obviously critical. Back to Gartner, they feel that by 2020, which keep in mind is just a year and a half from now, half of new user-facing applications that are developed by companies like yourselves will be event-driven applications. They will fundamentally have to be, because again, you will not be able to build these support these kind of use cases using a 3-tier database-centric application architecture. Of course, your applications need to be mission critical. They need to be built with security in mind right from the start. Obviously, a very important topic for all of us that are listening to this. They need to be reliable and scalable. These applications can't fundamentally go down. Right? Most event-driven applications need to be running 24/7, and you need to be able to, enhance them, upgrade them, debug them, do what is necessary while they're running, actually. Again, different than how most three-tier classic applications are deployed and managed. So that's very critical. And again, our friends at Gartner have said that event-driven architectures are actually the way of the future for building mission-critical applications at web scale. They are geared, they were built to be able to do that. And that's why they're so critical for mission-critical apps. We talked a little bit about the use cases that are distributed and or run anywhere. Those are two separate concepts. So first of all, run anywhere is the ability to run the applications you build, maybe in the public cloud on AWS or Azure, in your own private cloud, or maybe in your data center. So you need your system to be able to run the applications where they need to be run. And then possibly you need to be able to run them on the edge in distributed environments. Now, right now, most companies haven't yet fully embraced edge computing. It's still at the POC stage. It's in the science experiment stage at many companies. But that is changing very, very rapidly. And I think with the advent of 5G in the next couple of years, it's going to be accelerated even more. So the ability, as I said in the Tuja use case, to run applications close to where the data needs to be analyzed so issues of bandwidth and latency can be minimized. And then you send the data, only the data that needs to be sent to your core application. Then human-machine collaboration. You'll see a little bit of this in the demo in a second, but you can build autonomous systems. You can, of course, build applications that shut assembly lines down, or in the case of the field service example, shut off the water if there's a water leak in the apartment. But of course, so much more powerful if you can do that, but in addition to that, involve the people in your organization to address the condition in real time, prevent them from happening in the future, to optimize the state of your assembly line or your supply chain or whatever your scenario is. So powerful human and machine collaboration, and especially as systems become more intelligent, right? We talk a lot about machine learning, about artificial intelligence. As the systems we create become more capable and more intelligent, even more so they're going to be and have to be collaborative with the people in your companies to leverage their skill and experience, their wisdom and knowledge to make them more powerful, and for the people to make your systems more powerful. A true collaboration. Obviously, the folks at Accenture have been doing a lot of work on this, and they say that those companies that can really figure out how to invest and leverage human-machine collaboration will be dramatically more profitable than those that don't over the next 5 years. Now, okay, all that sounds great, but there's a catch, right? Building these kind of event-driven real-time applications, which companies have been doing for years, going back to Kix applications with mainframes, online banking, all kinds of things, airport control systems. Building these things has been possible for a long time, actually. And they are very, very hard. Building so-called reactive applications is non-trivial. Why? Because you're dealing with, streams of asynchronous events coming into your organization. There's no particular order. With standard BPM, you might have, if A happens, then a B, then C, then two Ds. With asynchronous data flows in the use cases we've been describing, you might never get an A, there might be 3 Bs, C is not relevant, and you gotta figure out how to do an E that you've never done before, okay? This is very complex to write software applications to handle these kind of use cases. And as I said, the data is continuously streaming in real time. You have to take an action now, not batch it and figure out what to do later. In many cases, these are becoming distributed systems and distributed applications. And then finally, as I said, most of these applications will involve people in some way or other. And people are the most asynchronous generators of data that you can imagine, of event data that you can imagine. And it can be, very hard to incorporate their unpredictability into applications, as you all know. So this is hard to do. And companies, as I said, have been doing it for decades. In fact, the middle part here is effectively a real-time event-driven application that's running the real-time supply chain of a global retailer who you all know very well. And you can just get a sense of the complexity of this ecosystem, all the tools, bespoke and open source, all the integrations and connections. When one of these systems or applications gets a version upgrade, everything has to be retested again. You can imagine what it would take to run this on the edge, on an edge gateway. You could never, frankly, run this system on the edge. And this took years, a team of gurus, years to build, test, and deploy. So it works, as I understand it. I'm sure it's a very competent real-time event-driven supply chain application, but who has even if you have the budget to create this, who has the time to do this any longer? Not many of you, I don't think, with the speed the world is now changing. So obviously what you need is to incorporate the principles of low code, no code, what Gartner calls high productivity application development to the context of real-time event-driven applications. That's really where the sweet spot is. And as Gartner says here, 2017 was really the first time that those two things were brought together. That you finally got, the notion of low code, no code, rapid application development, which has been around for quite a while, but finally joined to the notion of building real-time event-driven applications, abstracting away the vast majority of the complexity of building these real-time reactive systems and allowing you to even a mid-level developer, or maybe even somebody who's not a developer like me, build these applications, mostly visually, as you'll see in the demo in a minute. So as a before and after comparison, again, with the real-time supply chain example I showed, you've got, multiple tools and applications that you have to integrate together using a team of highly skilled developers, experts in each of those technologies, writing thousands of lines of code, taking months, if not years, to fully build and deploy, and then you have to maintain it, compared to doing it with VANTIQ, right? One platform, abstracting away the complexity, not guru level developers, virtually no code, and days or weeks to deploy versus months or years. We're actually very excited to have been recognized recently by the Software and Information Industry Association with their CODI Award as the best platform as a service, recognized by 800 of our software application peers. So very, very cool. Speaking of cool, Gartner also recently recognized VANTIQ as a cool vendor. So definitely you can see the before and the after here is quite startling. Now, VANTIQ was founded by two very experienced and successful software developers and entrepreneurs. In fact, VANTIQ is the fourth application platform that they've built either individually or together. They're famous for founding Forte Software in the late 90s, which was really one of the first application development platforms that was used to build the first generation of web application. The company is run by a very experienced team of professionals, global professionals who've had experience building and running, as you can see, numerous successful enterprise software companies over the last 2 decades. VANTIQ has customers across many countries and regions: China, Japan, South America, Israel, Europe, and of course the United States. Many of them have actually built applications in the area of field service, as we described the use case earlier, a very common source of applications that sense data coming in, do real-time analysis, and then take action in real time. Supply chain monitoring, I also discussed that use case. We've got one of the largest shoe manufacturers in the world as a client that is using VANTIQ to monitor and protect their brand in real time as the shoes they produce are shipped and distributed around the world. And then, of course, while many of these customers are B2B oriented, some are on the B2C side, like Hoplite Power, which is using a VANTIQ application to manage their real-time kiosk business, where they allow consumers to recharge their phones at a small service charge. So on both the B2C and the B2B side, many VANTIQ customers, and we'll be happy to talk to you more about that. And so that is the story of real-time event-driven applications. That's a little bit about the VANTIQ platform and how we fit into that ecosystem. And now, Brett, if you're ready, I'd like to ask you to do a demo and show us how you can build, deploy, and manage a real-time event-driven application using VANTIQ. Brett, take it away.
Thanks, Blaine. So we're going to take a look at VANTIQ, the application development platform for building event-driven systems. And what you're looking at on the screen is a representation of a canonical IoT example. So what we have is a set of pumps. They're emitting various data values like the RPM speed of the pump, the temperature of the pump. Obviously, pumps have many other values. We've kept this simple for demonstration purposes. And you can see this form that we've created, which shows us the location of technicians in the area who can potentially service these pumps should something go wrong with them, and some other graphical information that we see. If I drill down on one of the pumps, we get some additional detail, again, the temperature and RPMs. We also see some contextual information about where that pump is located, for example, its external location and its indoor location in the facility. So here we see that pump 1 is down here in the left-hand corner, but if I jump back and we click on pump 5, you'll see that that is in the upper right-hand corner. So what we're going to talk about is how you build event-driven applications using VANTIQ, and how you create these contextually aware applications that give you the ability to identify situations of interest, things that represent opportunities or threats to your organization, and act on them in real time. So more than just the dashboard that you're seeing. Although since we're on the dashboard, I'll point out that these web visualizations have also been created with VANTIQ. So let me switch over to the development environment called Modelo. And what I'll do is I'll click on projects and we'll just take a look at our pump client. And you can see this is a graphical editor that allows us to essentially move the objects about on the canvas. So if, for example, if I went to that second page where all the detail is and I wanted to put in an additional chart, it's drag and drop. So you've got this very flexible capability, nice, easy sort of drag and drop WYSIWYG interface for pulling information and attaching to various data streams, whether they're timed queries or maybe publishes on various kinds of events. So we can publish on an event in the system. It could come from MQTT or Kafka, all these real-time events for display. But additionally, we also have very powerful JavaScripting capabilities so that if you want to write custom scripting inside the application for maximum agility of the application, you can do that as well. But that's as far as I'm going to talk about in terms of the client. Really today, we're going to focus on how to build that back end, that real-time sensing, asynchronous, event-driven architecture, that event-driven application. And to do that, we're going to go ahead and switch over from projects to this, from this project to a project called the Pump Demo. Now, the only thing that I've got in here so far is just 2 subscriptions that are listening to the incoming stream of data. Now, that incoming stream could be coming from many places. I talked about a few a moment ago. We talked about it coming from MQTT. We talked about it coming from Kafka streams, or they could come from a WebSocket, or as it is in this case, they're coming in on a direct REST call on an internal topic to our system, in this case, stream temp and /stream RPMs. And I've created 2 subscriptions just so that we can actually visualize the data as it comes into the platform. You can see something interesting here. I've separated these 2 streams out so that I can show you some of the powerful correlation activity patterns that are built into the system that make it easy to essentially combine streams of data to identify situations or to essentially create situationally aware applications. So on one stream, I've got the RPM stream. It's showing the RPM sensor ID. It's showing the actual RPMs and the time. And then I've got my temperature stream, which is showing the temp sensor ID, a different ID, the temperature, and of course the time that came in. So somehow, even though there's no real relation to these 2, I've got to somehow figure out which RPM sensor goes with which temperature sensor. So the first thing we need to do is to create an application. And VANTIQ makes it really easy for you to create applications by visually modeling, by giving you declarative functions, and where you need that extra power, allowing you to script directly as well. So I'm going to come over here to the Add menu, and I'm going to choose Add App, and I'm going to create a new application here. Application gets a name. I'll just call this the Demo App. And you notice the yellow box. The yellow box represents what we call an activity pattern. And the activity patterns represent, sometimes dozens, hundreds, even thousands of lines of complex reactive Java programming that is authenticated and authorized, that requires, the appropriate security token. It requires, or it has the capability of being completely distributed and federated to multiple locations, so you can truly create a scalable application that, again, not only has those security principles, but also can scale to tens of thousands, even millions of events per second, if that's what the application requires. All of our applications start with the activity pattern called an event stream. In other words, what is the incoming event? And this one is, I'm just going to call this one sense temp, because what it's going to connect up to is our temperature sensor. And so I'll call it sense temp. I'll configure it. And again, it could come in, it could be inserted directly into the database. It could come in on one of those pub sub frameworks like MQTT. But as I mentioned earlier, this comes directly in on a topic. And this topic is called /stream, as you can see from the screen on the left, /stream/temp. And I'll go ahead and click on OK. There are some other optional parameters. We'll maybe discuss some of those a little bit later, and some of the things that they can do as well. But that's all I need to do. And then once I save it, you'll notice that our resource graph updates. It's constantly showing us what are the various components of our application, so we see all the constituent parts. And then you're also seeing this badge decoration, which is showing us the number of events that are actually coming into the platform. And as you can see, we're getting about 5 messages every 6 or 7 seconds or so. So that's the temperature sensor. I also have, of course, the RPM sensor. And so I need another event stream. So I'll add an event stream, and we'll call this one, not surprisingly, sense RPMs, and we'll configure it just like the last one. It comes in on a topic. And the name of that topic is /stream/RPMs. I'll click on OK, and we'll save it. Now, of course, we don't have to save every single time that we add something, but it is nice to see these sort of flags, if you will, that give us a sense of how our application is performing, that data is coming into it and it is being received. Now, what I need to do, of course, is because these are separate, is I need to correlate these into a single stream of events. Somehow I've got to create a relationship between our RPM sensors. Well, to do that, I've got a small lookup table that I've created that shows us that relationship. I'll show that to you quickly. And I actually called the table lookups. And what we see in the lookup table is that I've got a pump 1, and it knows about, or the supporting data is RPM sensor 1, with also temp sensor 1. It's got an indoor location, and it's got an external location. So basically GPS coordinates for the external location and flat XY coordinates for the indoor location. And that's how we were updating that map just a short while ago at the beginning of the demonstration. So I somehow want to take this data to enrich with context one of these streams. And so I'll right click and I'll link a new task, and I'll create an enrich activity, or I'll use an enrich activity pattern. And I'll call this enrich data. And so what I need to do now, of course, is tell the enrich data activity pattern how I'm going to correlate this information. So I'll configure it. I'll associate our lookup table. And then I have to specify the key or the constraint. What am I looking up? Well, I know I'm getting in the RPM sensor ID, or at least that's what I want to look up. But I'm taking in, from at least from the left side here, I'm taking in the temp sensor ID. So I'll use that as what to use in my lookup table to get the rest of the supporting information. So this will just simply be the temp sensor ID. And now once I save this, you'll see that as data flows through our application, it is then enriched with all of this contextual information for each one of the pumps that passes through it. So now that I have this contextual enrichment, if you will, I need to join these 2 streams of data. We have an activity pattern for that as well. So I'll link a new task. This will be a join activity pattern, and I will call it join streams. And then I'm just going to actually link the 2 of these together. So I'll do a link existing task. I'll choose join streams. And then the last step that I'll do here is to configure the item. And I've got to basically identify the constraint. What from the left side matches what on the right side? And in this particular case, it is the fact that I have enriched data going to the lookup table, looking up the RPM sensor ID, and matching it against the RPM sensor ID from the right-hand side, from the stream on the right-hand side. I'm also going to do a couple of other little things here. I'm going to say that these 2 events have to be correlated within 5 seconds. I could put 5 minutes, or I could put 5 milliseconds. I can specify the duration for this correlation to occur. And this is important, of course, because what if the temperature came in an hour later? Or what if the RPMs came in an hour later from the temperature? Is there anything that would assume that the temperature is still the same? So I'm correlating two separate streams and boxing it in a window of time to ensure proper correlation. And so this is the last activity I'm going to build by hand. We'll take a look at the entire application as it's built. But VANTIQ is also is not only a high productivity environment, it's in many instances a low code, but as you've seen so far, it has been no code. So in just a couple of mouse clicks, I have created an application that takes in two streams of data, enriched it with context, and joined them together. So let's take a look at the rest of this application. And so what you see on the screen here is we left off right here, join streams. Our next activity pattern is a transformation activity pattern. And so what we do in the transformation here, of course, is we've joined all this data together. Now what I want to do is set it up to be inserted. I want to store the last version of this. I want to persist the last version of this inside of our database. This, of course, is optional, but that's what I'm going to do with this transformation. And that is to take each one of the events that came out of our join stream activity and reformat them into our database format. So I want the location, the pump ID, the RPMs, temperature and time, and the indoor location. And then finally, I'm going to take the output of that and insert it directly into a type called pumps, and it's going to be an upsert. In other words, if it doesn't exist, create it, and if it does exist, then update it. And that's why if you take a look, I'll show you that table. So if we look at our pumps table and I run the query, there's our 5 pumps that are correlated with the current RPMs and temperature. If I were to delete all of these right now, the next time our correlation occurs, it all comes immediately right back. So we are persisting the last item inside the database. Now, another thing that we're going to do is we're going to take a look at our situation of interest, which is what happens when we cross some thresholds. This is a dwell activity pattern that uses a time in which the event has to occur for some period, right? So in this case, I'm saying that if I have a condition where the RPMs are greater than 4,250 and the temperature is greater than 198, and it stays that way for more than 5 seconds, not just one anomalous reading, then I'll move to the next downstream event. Now, this could be a complex algorithm. This could move to a machine learning, a scoring engine of some sort. It's simple here for demonstration purposes, but you can put anything in this condition. And if that condition is met for more than 5 seconds, then it will move to the next downstream event, which is our danger situation, or a danger activity pattern, which is a detect situation. And all this simply does is it records the fact that we have discovered our situation of interest, in this case, a threat to our business, and that we need to act on it. And so everything that you've seen here in the application is representing sensing and analyzing the incoming stream of data, and we haven't used any code in which to do it. However, now what we're going to do as we cross this threshold, as we cross this dwell pattern, and we create our danger situation, we are going to open up a collaboration. A collaboration represents all of the activities, all of the things that we're going to do to satisfy this situation of interest. And what you'll find out is that the reason that collaborations in the real world are much more complex than sending notifications is because there's lots of other events that are happening, right? The pumps are continuing to emit their various values, and state changes in those could cause new situations. The location of our technicians might have an impact on who actually gets assigned, which you're going to see in a moment. So let's move from our application to our collaboration. So we're going to open up this danger collaboration, which is triggered when we go over that usage threshold. So we come into this, it's initiated by the previous application. And then the first thing that you see here is a recommendation activity pattern. And what we're going to do with this recommendation pattern, we can use it for anything generically, but this one I've called VANTIQ, because what it's going to do is use GPS location. It's going to look in a table called technicians, or a type called technicians, And it's going to use a procedure called nearby recommendations, an out-of-the-box procedure for locating that technician based on proximity to the pump and where that technician is at the current moment in time. And we're going to find one technician. And when we do, we'll use an assignment pattern to simply assign that technician. And then we're going to do all of these things. So what's important to understand is even though these look like somewhat linear flows, we're dealing with an event-driven system. And any one of these things can actually, once this is initiated, these events can come in any particular order, and the system has to be able to deal with it regardless of how they come in. But once we've assigned the technician, we're going to notify the technician using our client builder application to send it down to the mobile device. And so here's take a look at this. It kind of looks like the screen we showed earlier, but this is just the one pump. It'll say that it's exceeded the temperature in RPMs for an extended period of time. It'll show the temperature in RPMs, and it will show the indoor and external location, as well as provide this little start conversation button. So we'll also show you a little integration with some third-party natural language processing sources. So we have our notify technician. That's what that does. It's also going to use a location tracking activity pattern. This basically uses the technician's location, their GPS location based on their mobile device to understand where they are. There's a number of things that we can do. For example, we can get updates every time the GPS sensor updates. We can trigger an event when they arrive at various waypoints, when they arrive at waypoint departures, if they're the first to arrive versus other arrivals and so forth. There's all these different things that we can do. In this case, I'm simply have on arrival, when they get within close proximity to our pump, we'll send them a text message letting them know that they're in close proximity. In fact, this is the first place that you see any code in our application. I'll show you that send text message routine. And as you can see, it takes in a message and a phone number, and then it publishes that message and that phone number to a source called Twilio. So here we're using a third-party source called Twilio, which is defined simply by showing the application, by inputting the application's security credentials and code. So it's like 3 boxes that you fill out, and it will then be set up to send to that source, so long as you have a Twilio account. And so that'll send our user a text message when they get within close proximity. Once that tech is notified, they get that mobile client that I showed you, and if they push that start conversation button, we'll then interpret anything that they say, and we'll process any intents that they have. The only other place that there's a little bit of code in this application is here in the custom intent. In other words, once we have returned from the natural language processing any entities and intents, then we'll use those entities and intents in a procedure to identify or tell the system what to do next. All right, so with that, let's actually take a look at this application running. What I'm going to do now is I'm going to raise the temperature, and we're looking at pump 5 in this particular case. So I'm going to raise the temperature and the RPMs on pump 5 so it crosses that particular threshold. And so let's do another thing here. Let's bring up my mobile phone. So you see the temperature has gone up. And in just a moment, you'll see the RPMs are going to go up. And then we're in that 5-second waiting pattern where the system is going to identify, whether we've crossed that threshold for 5 seconds. And once we have, you see it initiates the collaboration. You see my mobile device has just got the situation. It says pump 5 is having issues. So I'll open that up. As I look at the screen, I can see it says pump name, pump 5. I can see the actual temperature in RPMs. I can also see the location, the indoor and external location. But let's say I need some additional information. Here is where we're going to actually do a little natural language processing. So I'm going to click on the Start Conversation button. And what that's going to do, you see that it's opened up the Start Conversation. It's going to open up a chat. And so in this chat, I'll go ahead and issue a couple of commands. The first one that I'm going to issue is I wonder how, and there's our text message. So there's the text message. It looks like my technician, me, I've gotten within close proximity to that pump. So I'm relatively close, but I'm not exactly sure. I'm within a couple, couple 100 meters, I guess. And so let me go ahead and ask the system how far away I am. So I'll say something like, how long until I arrive at the pump? This goes out through the chatbot, integrates with natural language processing. It comes back, it says it will take approximately 2 minutes to get there. I'll say, can you send me directions to the pump? The system will come back and say, in this particular case, it says, no problem, I'm sending directions to your mobile. And if I were to actually go back and take a look, you see I have a new notification with directions to the pump. I've got a little bit of turn by turn, and I can also bring up the map with some additional information. So you can see very quickly, this application took about a day and a half to put together. So you can very quickly put very powerful event-driven applications together. So the last thing that I'll do here in this particular case, let's go back to our chat. Let's say our technician, remember our technician has this screen as well. And our technician says, you know, these operating parameters are just too high. We've also got some remote controls on these. I'm going to say, shut off the pump. And even though I didn't tell it which pump, because I'm in context of this particular situation, it will know which one. You can see it says pump 5 has been shut down. Temperature is cooling down. The RPMs will go down as well since the pump has been shut off. And you can see just how quickly you can put these applications together. Now, everything we've looked at to this point is represented the sensing and analyzing over the application. This represents the action on everything that we do once we've identified our situation of interest. Now, let's say we've got our application and we want to distribute it to our pumping stations all across the country, or whatever our application is. It obviously doesn't have to be pumping. It can be whatever your IoT or whatever your streaming application happens to be. So I'm going to move from the development side of the house to the operations side. And here in the operations side, I'm going to take a look at our deployment options. There's a couple things that you see on this particular screen. One is a list of nodes. Nodes basically represent a connection to other VANTIQ namespaces. They could be on this system, they could be on other systems. They might be, you know, down the road or in a complete, you know, in another state. The architecture is completely federated, and it is completely able to support any topological configuration with the security constraints that you have in mind. So in this particular case, this represents a connection from one node to another node, and I've also tagged it with this little regional property. By tagging it with that regional property, what I'm able to do is issue commands across that node so long as I have the appropriate security credentials. And as it turns out, our region 1 node also knows about some edge nodes. And so you can, again, create these complex topological configurations without having to be aware of the actual physical implementation. And so I've got these 5 regions that know about some subregions or some edges. I also have these things called configurations. And here you can see in the regional configuration, I've constrained it to all regional nodes. It contains the edge deployment configuration. So if regional nodes receive the edge configuration, they'll simply pass them down if they know about any edge nodes. And all of the other components that we've worked on, the Google Directions API that I use to basically get directions, the lookup table, the pump table, all of the components that make up this part of the application. What I can then do is publish those. And what the system will do is it will go out, deploy the application, and it will tell us which things succeeded, which things failed. I have one authorization issue in this particular one. So there you see the one deployment error, which happens to be invalid authentication information. This goes to the point that the system must be both authenticated and authorized to the given namespace or to the other VANTIQ instance that you're talking to, so that you have the appropriate security credentials that is necessary for these complex, what I would call business mission critical applications. And this also generates a nice diagram, kind of shows you the layout of exactly what was produced. So this system sent down those configurations to the edges, and the edges sent down, the regions sent down configuration to the edges. So we've got a little bit of hierarchical tree in here, we've got a little partial mesh down here and so forth. Again, you get to define the topology. Now, not only is it distributed, but it is also federated. And what I mean by that is it gives you the ability to query across the different environments. So the last thing I'm going to do in this demonstration today, from a deployment perspective, is I'm going to show you a distributed query. So let's go ahead over here. Let's go back to development, and I'm just going to add one procedure. And let's take a look at this this get pumps procedure. And here you can see it says select from pumps where the temperature is greater than 200. Now in our current namespace, no pump is operating over 200. So this returns an empty set of queries or an empty set of results. But if I add this process by statement onto it, and I say process by all nodes who have a regional property, well, any one of the other VANTIQ instances that has pumps where the pumps are operating over 200 will now be returned by this query. And so here you can see I have a much larger set of results. Some of these are coming from region 1, some of these are coming from region 5, and so forth. And again, you have this flexibility to run queries or run commands across the distributed environment. Last thing we can take a look at is we can take a look at a little integration with machine learning. And so what if I wanted to take, let's go back to our application here. And what if I wanted to take our application, which right now is doing a very simple overusage routine. It basically, if you remember, it looks for RPMs over 4,250 and temperature over 198. What if I wanted to use a machine learning algorithm to detect these anomalies or whatever it happens to be? Well, there's an easy way to link up to those third-party scoring engines if that's what we want to do. In this particular case, what I'll do is I'm going to show you a quick call to a machine learning algorithm. And here you see a procedure. It's called anomaly detection. The anomaly detection routine I'm calling is from Microsoft ML Studio. And so this is the payload that it's expecting. It's expecting an object in this format. And what we do is we abstract what that looks like so that I can call that like a SQL statement. So I say select from source pump anomaly, which here's my pump anomaly source, which identifies the URI and the secret key to call this particular third-party application. Select from pump anomaly with this as the body. And so here's a little sample, a little runtime version of this. If I just run it, you see it comes back with a scored label of 0 and low probability. So this is a normal reading. If I run it one more time and I set an anomalous reading, much higher values, you see the scored label comes back as a 1 with a higher probability. So this is our anomalous reading. So how can we hook that up to our application? Well, I'm going to go back to the pump app. I will right-click on our transform data. I'll link a new task. And this will be a transformation. And this will be called Anomaly Detect, or whatever you want to call it. I'll click on the configuration. And for the transformation, I'm going to use that procedure that I just showed you on the previous screen, which is the anomaly detection routine. That's all I really need to do. As soon as I save this, I'll immediately be running that anomaly detection routine. Now, of course, I only care about when the scored label is 0. I only care about the bad ones. So let's put in a small filter, and I'll call it the bad ones. And then for the filter, the condition that I'm going to put in is basically to say that the anomaly, event.anomaly, which is what's returned from the service, the score label equals 1. And as soon as I connect that into our danger situation, we'll link it to our existing task, and I click on save, you will see that it immediately starts executing our anomaly detection routine. And of course, it is now finding all of the one pump which is not operating correctly and identifying that. You're not seeing, though, any additional notifications on my mobile phone because that pump has already been flagged as a problem. And until our service technician fixes it, we only have that one situation. So hopefully that gives you a pretty good overview of the VANTIQ platform. Thanks for taking the time to watch the demo, and I'll turn it back to you, Blaine. Thanks.
So that is the story of real-time event-driven applications, and please go to vantic.com to find out more.